In this video, we are going to consider what could happen if something goes wrong, or what should we do to ensure that even if something goes wrong, nothing bad will happen to our data, or how can we prevent anything going wrong? Those kinds of issues. So let's look at some of the possible risks that we might have in our system, the library system. What could one of them be? We have an inconsistent update. Some errors occur as we are updating the uh, data, and the data becomes inconsistent. As an example, if we are issuing a book, we might be in the middle of updating uh, the objects. We might have updated the book object to say that a particular member has borrowed the book. But before we can get to the member object, something happens, either because the program has a bug, or there is a memory error, or there is lack of resources. Something happens and the second update doesn't get done. Then the data becomes inconsistent and we need to recover the data. Or it could be that we have the updates all done and we send the you member with the book in hand. We think we have issued the book in the system, but then something happens and the system crashes and the record in the object is lost. The memory contents are lost. What could happen? We don't want to have that kind of a situation where we have actually sent a member home with a book, but we don't have that recorded in the system. And what are other sources of errors? If you look at the design, when we are issuing a book or when we are creating a member or a book, we have references to books and members being sent to the user interface. So the user interface has an actual reference to an entity in the system, and it can use it to make changes. We don't want that to happen. A third thing, what if the user interface actually creates a member object and calls the member list object in the business side to insert that member without going through the library? Or what if it creates a book on its own? Or what if it directly calls a catalog method to delete a book? So we don't want any imported objects coming from the outside, and we don't want any updates done without the user interface going through the facade, which is the library. So let's look at inconsistencies because of errors. Let's assume that the programs are bug free, because if the programs have bugs, then um, all bets are off. The data could become inconsistent. So let's assume that all programs have been tested properly. There are no bugs in the program. It's a huge assumption, but we have to start from somewhere reasonable. So let's assume that we have a main memory system, that is, all the data is stored in the memory. Then what could happen is we could lose the data if there is a power outage or if there is an error. So what we could do in such a situation is to save the data after every transaction. What do we mean by a transaction? Something like issuing a book or deleting a book or placing a hold. All the updates necessary to carry out one unit of work, like a use case, completing an entire use case. So that is a transaction. So if we save all the data to disk after every transaction, nothing bad will happen, right? We know that all the data that we updated is available on disk. Of course, the disk can crash, but for that we can have backups and so on. Or it could be that the data is not completely in memory and it is backed up by a database system. So there is an actual DBMS, database management system, handling the data. In such a case, all commercial database management systems that is worth the money will support the crashing of the system. Any errors that can be caused will not result in the loss of data or inconsistencies. So we don't have to worry if there is a database management system supporting the data. Of course, you might ask, what is the feasibility? How feasible is it to save the data to disk after every transaction? If the data is large, then it is not an easy thing to do. Then we don't want all the data to be in memory. In any case, we want a database management system to support our operations. Now that we have talked a little bit about consistency issues because of failures, let's talk about code safety. Okay, to see what we mean, let's look at this situation. We have the design sending back a book object when a book is created. This is certainly not a good idea because the reference can be used by the user interface to make changes. A malicious user can get that reference to the book and make changes to the book, maybe delete the book, can do all kinds of things. We don't want that to happen. So how would you prevent such things? Instead of sending a book object, send a read-only version of the book object. What do we mean? Using this read-only version, you can only query the book. So this could be designed, this could be set up by having two types of book objects. One is we could call a full book, something that supports all the operations, all accesses allowed, all updates, reads, everything. The other one is a read-only book, which only supports getters. So the user interface gets a reference to a book, but the actual object, the actual type would be a read-only book, whereas the declared type would be a book. So the user interface should not be able to get access to, would not be able to get access to the books fields in order to be able to change those fields. So that would be a safety net here. Of course, how can you prevent those objects being removed? For that, you'll have to protect the catalog. We should not allow the users access to the catalog or the member list. That should only be accessible through the library. We will see those things taken care of in the implementation stage. So here is the organization for book. A book is an abstract class at the top of the hierarchy, and we have different versions of books. One is a full book, which allows unlimited access to all the fields. You can read and write any field. Then we can have different versions of the book class, like um, version 1, version 2, version 3. So version 1 might allow renewal but not removal. Version 2 might allow, or a different version might allow placing of holds and not allow something. So we can have different kinds of privileges for each type of book. Version 1 allows one type of privilege, version 2 allows a different type, version 3 can allow a third type, etc., etc. So we only talked about two versions in the previous slide, the full book and the read-only book. So what I'm saying is we could have many, many different privileges realized through many different subclasses of this abstract class book. So every full book remembers the corresponding objects, and these objects also have references to their full book, so that if you need the field, let's say the title, you can get it from full book. So version 1 can get the title of the book from full book. These versions don't maintain any of the fields. All the fields are maintained by full book. These are simply adapters. They are simply object adapters referring to the full book and getting information from them. And if the full book maintains a reference to each object of these different subclasses of books. We will not use this design in the implementation. This requires an elaborate construction, and this is called the protection proxy. There is a design pattern called proxy, which means standing in for something that is actual. So these are all proxies. Book version 1, book version 2, book version 3, they are all proxies. And they are protection proxies. They are there to protect the actual book. Instead of going through such an elaborate mechanism, we will use a different approach when it comes to the implementation of the library.